So right now, go on and open your book to page 310. Pause the video while you do that. And that's what we are going to be focusing on. This information you see, we're going to be talking about slope. Okay? So right now we're going to be reviewing a few things that we have learned. This says, you have used slope to describe steepness and direction of a line. Consider each graph shown. Identify the graphs whose line may have the given slope. Then describe your strategy for matching the graphs to the given slopes. Okay, so we're going to talk about this. I'm going to scroll down in just a second, but I want to read this. Remember, the rate of change or slope, constant rate of change, same thing as slope, of a line represents a ratio of the change in the dependent quantity to the change of the independent quantity. Remember, delta y over delta x, change in y over change in x. So what I want us to start with is a couple of the easy ones. So remember, we did slope face if you were here. We have this. Let's start again. Draw a circle. A positive slope, a negative slope, undefined slope. We generally don't have to focus on that. And a zero slope. Horizontal is 0. Okay? So if it goes up, that's positive. If it goes down, it's negative. If I have a vertical line, we call that undefined. And then we have a zero slope, which is horizontal. So we're going to use this to kind of help us along. So the easiest ones to start with would be B, zero slope. So anything that's horizontal has a zero slope. So C will only work with 0. Okay, so we're not going to use this one anymore. Okay, that is a zero slope, a horizontal line. Then the next one, when I look at these, I have a negative. Well, negative has to go down. So, nope. This one goes down. This one goes down. This one goes up. This one goes up. So it can't be these two. Okay? So I'm going to go on and cross these out because these only work for negative slopes. Okay? Now, the rest of these, honestly, because we don't know the axis, this could be either we don't know like what the numbers are on the axis. So what I would say though is 1/4. That's a smaller number than this one. So that means this one will be less steep. So I would say F and A are more likely going to be 1/4. And then 5/4, because that's more than 1, it gets steeper. That would be E. Now, 100% it depends on the numbers we use on the axis, but this is what I would say would be the graphs that go with it. Okay? So now we are going to move on to the next page. We're not going to talk about number 2. We're just going to move on to this. Good problem. So we are on page 311. It says, Ron has a player's card for the arcade at the mall. His player's card keeps track of the number of credits he earns as well as he wins the games. Okay, so as he wins, he gets more credits. Okay, each winning game earns the same number of credits. So an example would be if he wins one game, it's $5. Every game he wins would get you that many credits. Okay, and those credits can be redeemed for various prizes. I like to think of that as like at Chuck E. Cheese when you used to get tickets. Ron has been saving his credits to collect a prize worth 500 credits. The table shows the number of credits Ron had on his game card at various times today when he checked his balance at the arcade. So, when he hadn't won any, he started with 120. So remember, he's been saving these. Okay? So notice 0, 120, that starts right here. When he comes in, he already has them. He's not at 0, 0, okay? Because he has them. So then 12 would be at 216. Notice this is 200, this is 240, in the middle would be 200. I guess I should use a pen. 220 would be right in between, and he did a little below. So this looks like it's graphed well, okay? We don't see specific points, but that's okay. We could do 40 and 440. We can put a point there, okay? The rest of these, I usually say these are our betweens, okay? So this says, is the relationship proportional? That's this next question. Now we have focused on this for weeks and weeks and weeks. Is the relationship proportional or non-proportional? This is non-proportional. Why? The line, or I was going to say the graph, the line of the graph does not go through 0, 0. If it goes through 0, 0, and it's linear, then it's proportional. This is linear, but it's linear non-proportional, okay? So, and we already talked about this. Explain the meaning of the ordered pair 0, 1, 20. He started with 120 credits. Remember, he was saving. So I'll just say credits, period. Because he was saving, I could add that on. Use the graph to determine the slope of the line. So y'all know for the slope, we already can tell this is linear, so I do not have to go all the way down on these, okay? I can just choose any, delta y over delta x, okay? So in your calculator, you would subtract 216 minus 120, and what do you get? 6, this would become an 11, that would be a 9. So delta y is 96 over 0 to 12, so this is 12, right? So delta y, it changes by 96, the next one is by 12. Delta y over delta x. If you put this in your calculator, if you divide that, you should get 8. Now, just to make sure that I'm telling you this correctly, you can do this. You can choose any other 2 points. It doesn't matter. I know it's going to work. I'm certain. Okay? 440 minus 320. Delta y here would be 120. Over here, 40, 25 to 40, that would be 15. So delta y is 120. Delta x is 15. When I divide it, I get 8. So the slope of the line is 8 over 1, or 8. So what does that mean? 8, or 8 over 1, it may be easier to explain it this way, basically means that I get 8 credits per game or per win, right? Per game or per win. I'd have to see what the table says. The table says, yep, based on how many they won. Okay, so that's our slope. It's 8 or 8 over 1. Okay. So we're going to skip this. Actually, we'll go on and do it. This says, before Ron started winning games today, how many games had he won for which he had saved? So remember, he started with, was it 120? I cannot remember. Let me go back up to the problem. He had started with 120. So how many games had he won? Well, in order to get 120, and it's 8 per game, I would just divide that, right? I could set this up as a proportion if I wanted to, because it is proportional. 8 into 40 goes 5. So he had won 15 games, okay? And that gave him 120 tickets, okay? After Ron won his 40th game today, how many more games does he need to win in order to collect a prize? 500 credits. Now, the important thing here is it says after the 40th game. After the 40th game, okay? So, So I'm going to go back and look at what it was for 40. Let's see if that was in our table. So at 40, we already had 440 tickets, right? So we have to figure out how many more we need. So we want 500, and sorry for the constant interruption. 500, we have 440, which means we need 60 more, okay? So I have to figure out how many games I need to win, okay? So 60 divided by 8. So divide that really quickly and let's see what we get. 7, 56, 4, I have a remainder of 5. So 7.5. So if I win 7 games, I'll only have 56 tickets. So I actually need to win 8. Okay, so I need to win 8 to have enough.
We are ready for the students who are on the first floor that have earned the privilege to go outside. Those of you that are on the holdback list, you're walking with your teacher. Teachers, please escort those students that are not going outside to the auditorium and then report outside to your duty station. Again, we are not sending students to the auditorium by themselves. We are escorting them to the auditorium, and then if you'll head on outside for